So, the marks achieved by 10 students for each of their 2 Learning for Life and Work coursework pieces are recorded in the table below. First piece, second. Find the rank orders for each of these pieces of coursework. Okay, so we have a look then, so we're going to rank them. So we'll start and we'll rank the first mark. So have a look at this then. Let's see. 47 is 1, 46 would be 2, 38 would be 3, 36 would be 4, 35 would be 5, 34 would be 6, 33 would be 7, 32 would be 8, 26 would be 9, and 22 would be 10. So that's the ranking for the first score. We have on the second score. So 36 would be 1, 33 would be 2, next would come the 228, so they would be 3 and 4, so they get the average of that, 3.5. So 3.5. That was 3, 4, so 25 would be 5. Then we have 2 22s, so they would be 6 and 7. So 24 would be 6. Then with 2 22s, they'd be 7 and 8, so they'd be 7.5 each. 7, 8, so then we have 9 would be 20 and 10 would be 16. So that's them put into the rank order. Next thing we have to do then is calculate the Spearman Rank Coefficient. Okay, so the formula for the Spearman Rank Coefficient is R equals 1 minus 6 sigma d squared over n times n squared minus 1. Okay, so we'll have to get d squared then, so getting d from our ranks. Okay, so the difference here is 0.5, 3, 2.5, 3, 0, 1, 0.5, 1, 4.5 and 4, and squaring those is going to give us 0.25, 9, 6.25, 9, 0, 1, 0.25, 1, 20.25, 16. So if we add that up, sigma d squared then is 63, n is 10, so r is going to be 1 minus 6 times 63 over 10 times 10 squared is 100 minus 1 is 99. 34 over 55, which is 0.618. Okay, so the significance of that value would be that you would have a positive correlation between the rankings of the first and second scores. And marks for coursework. Okay, now next we're asked calculate the mean score for each past piece of coursework. Okay, so if we put that into our calculator, we get the first is 34.9 and the second is 25.4. Okay, so then we've got a next question, we've got the data, draw a line of best fit. Okay, so let's have a look at our graph. The first thing we're going to have to do for this graph is plot the two means. Okay, so here we go, here's our graph. I'll try to get the most of it in. Okay, so we're looking to plot the point. First average 34.9. Okay, so for scale, halfway would be 34. Halfway would be 35. So it's just about here. And then 25.4 on the horizontal axis. Okay, so that's 5. So every 2 is 1. So we'll go up here. 25.2. That would be 26, so 25.9 would be about there. So we're talking somewhere about there for our line at best. If it has to go through that point, so we'll get ourselves a ruler. Now we want 5 points either side of that going through there. So let's have a look at that one. Okay, 2, 4, 5, 6. Okay, we'll just bend it a little. There we go. There's 5 on one side. And 1, 2, 3, 4. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where's the other point? There's 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're not going to get. Okay, so there's 4 on either side now. Okay, I think that's close enough. Line of best fit. Always go through the two means. Will be an acceptable line of best fit. Okay, so then next we're asked, what's the line, the equation of the line? Okay, so we know it goes through 34.9, 25.4, and get another point that goes through. Okay, so there's 1, 2, 3. Okay, so it's going through 2013. Okay, so then we can work out the gradient. So the gradient is difference in the y, so it's 25.4 minus 13 over the difference in the axis, 34.9 minus 20. So that turns out to be 12.4 over 14.9. And then we use y minus y1 equals m times x minus x1. So y minus 13 equals the gradient we've just worked out times x minus 20. And then simplify that and that'll give us an equation of a line.